Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Iman bin Bahrin and my matrix number is DE 200 116. Okay, I will explain for chapter 3 methodology process. Okay, uh, as you can see, this is our group project flowchart, and we start the project with doing literature review to find a suitable material and design to create an insulator. Then after we find uh, the material and design, we discuss with the group mates and decide the material that we will be used for create the insulator, and we choose pin-type porcelain insulator. Then we define the insulator test objective that we want to achieve. First is high voltage, and second one is electric field. Then we create the design, the insulator design using AutoCAD software, and uh, we analyze the electrical and mechanical performance of insulator using finite element analysis method on SolidWorks software. Then we collect and observe the data based on the performance testing. Then if the testing is unsuccessful, our group do an adjustment on the design to make sure that the design meet the specification requirement. Then we have to do the analyze electrical and mechanical performance again using finite element method. If the testing successful, we documentation and finalization the data. For the next part is flowchart explanation. Okay, as I explained just now, for this part I explain what tasks that our group do based on flowchart process. So as we can see, student conduct an experiment with 33 kV insulator. Then literature review, we do literature review to find several materials and design. Then consult with group member, discuss with group member to choose the material and design. Then we choose porcelain and pin-type insulator. And then we define the goal that we want to achieve through this experiment. The goal insulator must be high voltage resistant and electric field. Okay. So next is step-by-step production of the insulator model and simulation using AutoCAD software. And then we upload to the SolidWorks software to perform an electrical and mechanical performance analysis, as I said just now, using finite element analysis technique. And then we note and record the simulation data to be analyzed and observed, and the data produced must be in accordance with the specification and requirement that have been set for the production of an insulator. If the testing fail, so we have to do an adjustment and do the simulation again, and if the simulation is successful, we will record the data and documentation. So that's all from me for chapter 3, methodology process, flowchart and explanation of the flowchart. So thank you.
A very good day to Dr. No Diana and my fellow teammates. Okay, I'm going to present a simulation of the pin-type insulator FEA analysis. So here we have our 33 kV pin insulator, which is a porcelain type. So here's our design, and we are going to have a material configuration. So as you can see, I'm using the GMX software. So this is a custom material of porcelain, so I'm going to edit. So I'm going to put in all those data, and I'm going to have the resistivity, mechanical, thermal, lost. Okay, so we are using a 60672 type C 130 porcelain type. Okay, so first we are going to have all those settings of the tree lightning, surface charge, force, electric field boundary, and insulator. So as you can see, we can see the condition over here, and then we have our mesh regions, which is I'm going to regenerate the entire mesh, so I'm going to add these parts. So I have these ones. This is meshed. Okay, so we need to add these things. Okay, so yes, okay. So we have this one mesh, this one is mesh. Okay, so we're going to have generated. Okay. Okay, so we're gonna have this one and a region. Okay. So we have all other basic shape over here, which is a 2D shape. So as you can see over here. Okay. So basically, okay. So for the drawing here, we are going to use the conceptual mode, and we're going to extrude the surface, which is here, maybe top 5 cm. Okay. So, and the other surface over here, we're going to extrude the same, which is 5 cm. Okay, so and we're going to use the isometric to see the surface. Okay, so basically we are using this one to do extrude all the surface of the entire drawing. Okay, for the import CAD file, we are going to use this one, and we're going to import a CAD file. Okay, so basically we have over here, we are going to use the H3 lightning, surface charge, force, and electric field. Okay, so as you can see here, we're going to have our mesh here. So we're going to add our mesh. So our mesh. Okay. We're going to generate the mesh. So basically, we are using the FES simulations, and we're going to apply the 300 kilovolts of the lightning test. Okay. So you can see here, this is the mesh. Okay. So we're going to have our contour plot, and we're going to run our test. So this basically we are running solver, and we're going to solve it, and we're going to have the results of model force, electric field density, and then a contour and vector plot. Okay. Okay, so we have our vector plot, and this is a model force. Okay. So we have electric potential, current density, force, electric field. This is a normal electric field, as we can see over here. We have the maxima, and then we have you can see we have all those steps and phase. Okay, and the surface charge density. Okay, so normally this is the analysis of our FEA.
Very good morning to all the lecturers.
Hello and a very good day to Dr. Northiana. My name is Kanchan Phai with the matrix number A190091. from Section 2, Group 5, and in this part of the video I shall be presenting on the discussion part of our group project. So, from the results that we have acquired and the observations regarding on the material that we had chosen in our project, which is porcelain, of the tests that we have conducted, tests such as the FEA analysis for electric potential and normal forces. You can see that the simulated model, that the nodal forces and electric potential are in the green when 300 kilovolts of electricity reached it, which is the usual lightning impulse voltage. That means that it can withstand 300 kilovolts of electricity and distribute the energy successfully to avoid failure for that material. And aside from that, the analysis, the observations that we have made from the analysis was that the surface charge density of the pin insulator is that the top part has a lower surface charge density than the bottom part when the 300 kilovolts of electricity struck it, which means that electricity would flow from the top to the bottom, which is important as the direction of the flow of the dissipating electric energy must be in one single direction. And aside from that, from other than that, the observations that we have made from the FEA analysis is that the nodal force in both contour and vector plotting are distributed evenly at the area closer to the center of the pin insulator, whereas the higher forces are seen near the curved edges of the individual insulator disc, or in other words, ring shaft. This is a good sign as high nodal forces that are present nearer to the center will weaken the insulator from the uneven stresses that are acted upon it, causing cracks that will inevitably damage the pin insulator severely. Lastly, the observation that we have made for this material from the FEA analysis is that the distribution of the normal electric field in both the contour and vector plot of the pin insulator is converging under the individual discs and nearer to the middle and bottom of the pin insulator. This means that electricity is flowing and dissipating from top to bottom. The analysis of this material that we've chosen to be a pin insulator for high voltage transmission lines, which in this case is porcelain, was able to be done. And the results from FEA analysis that we have acquired are quite promising. However, this is only simulation, as in the real world, debris or dust or other alien matter that build up on these pin insulators over time will cause a different outcome to their capabilities to withstand lightning strikes or other forms of over voltages. Okay, that's all from me. Thank you very much for watching the video. Thank you.
Who is watching this video presentation today. My name is Lee Jinzhou, and now I'm going to present with you about the conclusion part of FEA and also the HV testing for Section 2, Group 5. So, firstly, let's look at the conclusion of FEA. And the most used material for overhead insulator nowadays is porcelain, and it is made of aluminum silicate. And to create the final hard and glazed porcelain insulator material, the aluminum silicate is combined with plastic kaolin, feldspar, and quartz. And the insulator surface needs to be sufficiently coated to prevent water from being trapped on it. And the C130 aluminous porcelain is compared to the entire database and other oxidized base technically a ceramic using the graph bar on the material characteristic card. And although C130 has the best strength to weight ratio, there are large variation in its composition and qualities, which affects how well porcelain insulator works. And the pin, which included a screw that is used to secure the insulator to the cross arm, is located on the bottom side of the fitting, and to secure conductor header fitting often has a groove form, and there are three different types of overhead insulator, which is the strain insulator, suspension insulator, and also the pin insulator. While the pin insulator differ from the others in that they are physically attached to the support rather than hanging from it, and the conducting wire can be attached securely to the pin insulator, preventing it from breaking loose. And finally, from the result we have occurred through FEA analysis, we believe that porcelain is a suitable candidate as a material to be used and manufactured into pin insulator and be utilized on high voltage scenarios such as high voltage transmission line, and this is because it had passed the stress test that concern with overvoltage situations such like lightning strike, and the pin insulator was able to withstand 300k voltage of electricity and dissipate it without being severely damaged as seen from the nodal faults. And these pin insulators are at the front lines of providing protection to transmission line, as failure to provide such protection will cause cascading problem throughout the entire power transmission network. And that is all from the conclusion of FEA. Next, we are going to the conclusion
Afternoon
of.
to my lecturer, Dr. Nodiala, and my teammates. My name is Listen. So let me continue the risk assessment HP testing proposal. So this is our title: Switching and Lightning Impulse Test on Ceramic 33 kV pin insulator in medium transmission line. So the certificate diagram is also the setup. So next is the important part, risk assessment. So there's two possible consequence. So one is every shock and fire, but in the rating there is there is there is can control it, monitor it, and and manage it. If there is important part needs to wet the PPE before running the experiment or for operating the electrical shock. For firing, need to prepare fire extinction. So also make sure all the conditions are tight because prevent some arcing happen. So that's risk acceptable for two possible consequences. So next is about the hazard checklist. So need to check about the pressure of non-hazard type. So let me explain one. So every shot for high voltage, so there's not person. So every shot for low voltage is person. So tripping hazard is a person. So this all from me. Thank you.
So now we are going to look at the conclusion for the HV testing part. So in the conclusion, the high voltage testing part did show members of the group how to handle risk and overcome the problem faces when testing high voltage, and the guidelines that related to the safety of tester were followed correctly to make sure the tester would work in a safe and guaranteed places. And the performance of 33 kilovolt pin type insulator will be assigned during the scheduled HV testing. A suitable high voltage power source, safety protocols, and specific testing like switching impulse and lightning impulse are important elements. It withstand voltage, waveform feature, and reaction to transient will be determined by the result, which will give important information for judging its reliability. This testing proposal did find some ways to overcome the problem and also help improve the way of testing high voltage in the future. So thank you very much. That's all from us.